Assalamualaikum warahmatullahi wabarakatuh. In this video, we will discuss on off delay timer and RTO. Alright, so in PLC programming, the on delay timer or T-on timer is by far the most commonly used type of timer. Most people consider on delay timers to be simple to use, right, and really simple to understand. In comparison, many people find the operation of the LMW off delay timer to be less intuitive. But let's see if, and let you decide by yourself which one you want to use for your own application. Right? So for the off delay timer, one of the application is to be used in air conditioning systems to hold the blower motor in operation for a specific time period after the thermostat has turned the cooling compressor off. And then it can also be used in electrical devices to operate electrical devices and motors for a specified time, such as coin-operated dryers, for example, in commercial laundries, right? Okay, so right now we have our interface of ladder diagram. So I have already started with this ladder diagram. So this one is off delay timer, similar to on delay timer before. So if you missed the on delay timer, you can go to our previous videos. So off delay timer, similar to on delay timer, we have 3 bits that we can use as input to other rungs, right? So it is similar, so it has the time base, alright, preset, and also the accumulator, where the accumulator will be used to indicate the counting process of the timer up to the preset value. So for example, for this one, you have the 5-second counting, and then you have the enable bit, timer timing bit, and done bit. So let's see the simulation in this I/O simulator, right? So I've put here the toggle switch just to make sure that we don't need any latching. So if you use, you right click, you can change this to multiple switches. So you can also use push button, but if you use push button, you need to add the latching circuit here. Alright, so let's say we run this. Okay, let's download first. Alright, run. So we toggle the switch now, and then we can see that when this one is activated, there's a signal coming in to the timer, but see that the accumulator is still not counting yet, right? But when the timer rung is activated, you can see that the enable bit and the done bits is already in activated position. Alright, so if you see you can see the truth table again. You can see the table, right, of the off delay timer. So you can see that the timer enable and timer done bit will be true if timer rung is true, right? So as for the done bit, timer rung is true, or the timing bit is true, meaning that the timer rung is true, or the timer will start counting. Alright. Okay, when the timer timing will start? Timer timing will start when the timer rung is false and the accumulator value is less than preset value. Alright. So the timer will start counting when we release this, right? When we make this open, or in other words, we change the state of this rung from true to false. Okay, true to false. Right. So how to make the bit false? Right. So for enable, is as simple as make the timer rung false. So when this one is false, enable will be false, and then for the timer timing, it will be false when the timer rung is true. Alright, or the accumulator is equal to or greater than the preset value, or the done bit is false. Right, so it has 3 conditions, to make it false. Right. As for the timer done bit, it will be false when the timer rung is false and the accumulated value is equal to or greater than the preset value. Alright, so let's see the simulation now. To understand more clearly, let's open this circuit now. Right, when I open this, now you can see the accumulator is counting up to preset, and then you can see that all of this have been deactivated. Right, you can see here all will be false when the timer rung is false. Right, one timer rung is true, or the accumulator is equal. So now you can see that the accumulator is equal to the preset. Alright, how about the done bit? Done bit will be false when the timer rung is false and the accumulator is equal to or greater than. Alright, so you can see here. Alright, one important thing to note on this off delay timer is that when the accumulator will be reset. Alright, so we know that the timer will start counting when the timer rung changes state from 1 to 0, and this accumulator will reset when it changes state again from 0 to 1. Right, so let's try to simulate to see the condition. Right, so now start counting. Right, reset, counting, reset. Okay, we'll count up to 50. Up to 50, and then reset again. Okay, so let's move on to the next timer, which is RTO. RTO stands for retentive on delay timer. Right, so let's replace this off delay timer with RTO first. Alright, we delete this, and then we go to this one timer counter. So this one is RTO. Okay, so we drag this. Okay, now we have the timer. Just put the same address as before, so that we don't have to change the address again. Okay, T40. Alright, let's say it is 6 seconds now, right, and the accumulator will be 0. Okay, so simply speaking, an RTO timer functions exactly the same as on delay timer, T-on, with the exception that once it has begun timing, it beholds its count of time even if the rung goes false. Right, if in on delay timer, if the timer rung is false, the accumulator will begin to reset. Right, but for RTO, it will retain the same value, and then if it is triggered again, it will start counting from the retented value it holds. Okay, alright, so let's see how it works by simulating it here. Alright, so the same, it has the enable, timer timing, and done bit. Now let's simulate the RTO in our simulator. Alright, so when we start this, we start counting, and when we stop, for on delay timer, this one will be reset, the accumulator will be reset. But for RTO, this one will retain, the value of accumulator will retain, and then when we start again, it will start counting from this retained value. Alright, so let's see now. Yep, stop, counting again, stop, counting again. Alright, so it's exactly the same like on delay timer, but the accumulator will be retentive. Okay, so now comes the question of how do we reset the accumulator. Right, as we know that when we count this one up, we will go up to the preset, right? So for the on delay timer, we can simply toggle the switch to make this reset, to make the accumulator reset. But for RTO, we need another thing to reset it, right? So we need to add one reset button here, right, just to reset the timer. Okay, right, so as for the address for the reset, we need to use the same address as the RTO, so we can simply drag here, right, and put some new input, right, to reset. Right, so let's say this second input here to reset our RTO. Okay, so let's download program and run. Okay, so try to reset. Now it can reset, right? So reset, right? Reset to 0. Okay, So that's all for the timer. So you have the on delay timer, off delay timer, and retentive on delay timer.